Welcome to my video over tangent line theorems. So we're going to start off with our first theorem is a line is going to be tangent to a circle if and only if the line is perpendicular to the radius drawn to that point of tangency. Okay, so for example, in this picture here, we would say that our radius, which would be the segment CB, would be perpendicular to that tangent line. We would have AB, right? AB. And then we can do the same thing with the other radius. So here, if we have our radius CD, it would be perpendicular to that tangent line, and we'll call that our ray AD. Okay, and so here we would just have our right angles being drawn where those tangent lines intersect the circle at one point. Okay, and then moving into our second theorem, we have tangent segments from the same exterior, so outside of the circle, point, are going to be congruent. Okay, and so what we're saying here, using this picture, is since we have this exterior point of A, from A to that point of tangency, D, that segment would be congruent to A to the point of tangency of B over here. And so we're going to write AB is congruent to AD. And then lastly, we're just going to mention that if a polygon is circumscribed around a circle, then all sides are going to be tangent. And with that being said, we actually can use that theorem from right above as well to state that all of these segments should be congruent to each other. Okay, noticing that the congruent segments are only coming from that exterior point to the points of tangencies. The only ones I can safely assume would be congruent to each other. All right, and then we have our common tangents. And so for here, we have our internal common tangent. And so from this point of intersection between those two circles, kind of using that theorem from up above, we can say that these segments are going to be congruent to those points of tangency. Okay, and then you have your external common tangent. And so we can say that from this point of tangency to this one over here, this segment is going to be congruent from this point of tangency to this one on the other circle. All right, now let's apply these theorems to solving in these problems. So for number one, we have given that BC is going to be 3 and AF is going to be 9.5. We want to find DE, so I'm going to call this X, given that my perimeter, my P, is going to be 50 around that triangle. All right, so we can apply the congruent segments that we had just talked about over here to say that this length will also be 3, that this length down here will be 9.5, and that this length will be X. Okay, so I can write an equation here to say that 2 times that 3 plus 2 times 9.5 plus my 2x is going to be equal to the perimeter of me adding all those sides of 50. Then I'm just going to go ahead and divide everything by 2 since I see that in every single term. So I'm going to get 3 plus that 9.5 plus x is going to be equal to 25. So combining my like terms here, I'm going to get 12.5 plus x is equal to 25. And when you subtract, you should be left with your x is 12.5. Okay, and so that's going to give me my answer that DE is going to have a length of 12.5. All right, now let's move into number 2. So in number 2 here, we are given that AD is equal to BD. So AD is going to be equal to BD. Which is also equal to 16. So here we would have a length of 16 on each one of those. And that EC is going to be 12. Okay, so from E to C, that's 12. That is a radius, and therefore I can mark any other radius as being that length of 12. So I'm going to call CF also 12. Now I'm asked to find X. So I'm going to call that, I'm asked to find AE. I'm going to call that X. So with that being said, what I can do is I can create a right triangle using a radius to that tangent line. And so we can use Pythagorean theorem. Now remember, you do need to know 2 of the 3 side lengths in order to use that. And keep in mind, once again, I drew a radius from C to D. And so this is also going to have a length of 12 as well. Okay, so plugging into Pythagorean theorem, I'm going to have my 12 squared plus 16 squared is going to be equal to the length of from A all the way to C. So here I'm going to have to use my segment addition to say that that will be x plus 12. Okay, and so I'm going to just write x plus 12 here squared. All right, keep in mind, and I'll do a little bit of scratch work for those of you that need to see it, that x plus 12 squared, okay, is actually going to be x plus 12 times x plus 12. Okay, a lot of y'all do forget that when we have that parentheses there. We are going to have to FOIL this out, and so we'll get our x times x gives me x squared, plus, and we'll have 12 times x, so 12x, plus another 12x, plus, and then we'll have 144. Okay, so combining my like terms, this is actually going to end up being x squared plus 24x plus 144 here. So I'm going to come back over here and let's plug that in. We'll have 12 squared is 144 plus 16 squared, which is 256, is going to be equal to that x squared plus 24x plus my 144. All right, and what I can do here is I can end up factoring if I set this equal to 0. So I'm going to move everything over so that I have 0 on the left side. And I'm going to get x squared plus 24x minus 256, because that 144 will cancel out with the other one. It's going to be equal to 0. Okay, and then I want to think of what are 2 numbers that will multiply to give me that 256, that negative 256, but will add up to the positive 24 that I need. Well, right off the bat, for me, I know that I could say that this would be x minus 8 and x plus 32. Okay, and so that's going to be equal to that 0. And then I want to solve each one of these to figure out what are my options. And so here I would have x is equal to 8. And then using the other one, I would have x is equal to negative 32. Now, remember, x is a length. Okay, and so with that being said, we don't want anything negative because you can't have a negative length. So my answer for my x would just be that x is going to be equal to 8. And since they're asking for the length of AE as your answer, which I just called x, I can say that AE is going to be 8. All right, now let's move into number 3. So we have a belt fits tightly around 2 circular pulleys as shown. Find the distance between the centers of the pulleys. All right, so I am looking for, in this problem here, the length from these 2 centers. And so what I want to keep in mind is that 35 inches here we can assume, and usually we wouldn't want to assume, I would put in the instructions somewhere in there that lines that appear to be tangent are tangent. But we can say that line is going to be tangent. And remember, you can say that it is then going to form that right angle here. And so what I can do is I can split this up into a rectangle and a triangle. Okay. And so with this being a rectangle, we know that our opposite sides are going to be congruent. So this part of it will be 8. So what I can do to find this missing length here is I can take that 14 minus 8 to get 6. Okay. And then just talking about a little bit more about our drawing here is when this is a rectangle, remember these 2 lines are going to be parallel. And so I can use our corresponding angles to say that this here is going to be a right angle, which will allow me to use Pythagorean theorem to find the length from center to center. Okay, so I can also say that this will also be 35 inches. And so using my Pythagorean theorem, I'm going to plug in, we'll have our 6 squared plus 35 squared is going to be equal to that c squared. Okay, so if you know your perfect squares, 6 squared is going to give you 36. Plus we have that 35 squared is going to give you 1,225. Is going to be equal to c squared. When I combine those two together, I'm going to get 1,261 is equal to my c squared. And so I'm taking the square root of that to find my c. Now, you want to then turn around and simplify the radical as much as possible for your final answer. You might result in a perfect square and get a whole number. You might have to simplify and leave it as just your simplified radical. In this case here, we can try breaking it down, but the only factors that I can find are going to be here 13 and 97, which isn't very helpful because that 13 and 97 are both going to be prime. And therefore, when I try to simplify this radical, I'm not going to have any pairs to pull out. And so my final answer is just going to be the square root of 1,261 inches. All right, now let's move into number 4. So we are given here that the measure of angle EML is 66 degrees. Okay, so EML is going to be 66 degrees here. And that MK is 15, which MK is a radius, and so any radius we can mark as being congruent to that 15. And lastly, we are given that KL is going to be 36. And so that is going to be from a point of tangency to an exterior point. And so over here from E to L, I can say is also going to be congruent to that 36. So we are asked to find the measure of angle MKL. So just kind of looking at that, we've got MKL. That angle here, I did already mark as a right angle. So that's going to be 90 degrees for that answer. Okay, then moving into, we have the measure of angle ELM. So starting at E, then going to L, then to M. So this angle here we want to find. Well, what I can do is I can kind of focus in on the fact that I do have this right triangle being formed. And in that right triangle, okay, we know that we have that right angle at 90 degrees, that's 66. And so I can subtract those two from 180. And I'm going to be left with 24 degrees for that angle. Okay, from there we are asked to find the length of EL, which I already did. I mentioned earlier that EL was congruent to that 36 that was given. So I know that length. And then we are asked to find in the next one the measure of arc KPE. Now, keep in mind, we are asked for the measure of that arc, not the arc length. So our answer is going to be in degrees. We're not plugging in for arc length. So KPE, we're going to start at K, going towards P, and then over to E. We're asked to find the measure of this arc. Now, keep in mind, we do have that 66 degrees given for that central angle, EMP. And if you haven't noticed yet, but we do have congruent triangles being formed here. And so I'm able to say that this angle over here is also going to be 66 degrees. And so I can just double that, 66, to get my answer. All right. Now for the next one here, we're asked to find the measure of ML, the length of that segment. Okay. And so in order to find the length of ML, we are going to focus in once again on the right triangle. So using Pythagorean theorem, we are going to say we have that 36 squared plus the radius that's given to us, that 15 squared, is going to be equal to that c squared that we're trying to find, that ml. So 36 squared is going to give you 1,296 plus 15 squared, 225. When you combine your like terms here, you're going to end up with 1,521 is equal to that c squared. Then I'm going to take the square root of it, and we are going to simplify the radical if we can't, get a whole number. Okay, so do not leave it as just that 1,521. You will lose points. You need to simplify the radical to see what your final answer is. So what I can do is I can break that down. Okay, so if you know your trick here, if I add up each digit, so 1 plus 5 gives you 6, plus 2 plus 1 will give you 9. So since the sum of those digits is a number divisible by 3, 9 is divisible by 3, that number there is divisible by 3, so I can factor using 3, and I would get 507. Okay, I can use that same trick once again to get that 5 plus 7 is 12. So I can break that down into 3, and we would have 169. Okay, which when I get to that 169, I do know that that is going to be a perfect square. That's going to be 13. And so I can pull out my 3 times 13 to get 39. So here, ML is going to have a length of 39. And then moving into that length of P to L. Okay, so let me use a different color here since I've got a lot going on. From P to L, this segment length is what I'm trying to find. Well, once again, remember that M to P is a radius, it's 15. And we just found out that M to L is 39. So I can subtract that 39 minus my radius of 15. And I'm going to be left with 24. So 24 is the answer for the length of PL. Okay, so now we're going to flip it over to the back side and look at our last two problems. So for number 5, we have circle C is inscribed in the quadrilateral. We have X, Y, Z, W, and we're asked to find the perimeter of that quadrilateral. Okay, so this is going to go back into that second theorem that we had talked about on the front side, which is telling us that from that same exterior point to a point of tangency, we know that those segments are going to be congruent. So here we can say that this segment is going to have a length of 6. We know that this segment is going to have a length of 7. This 11 can be carried over here to XU. And then that 8 is going to be congruent to this missing segment over here. Okay, so what I can do to find that perimeter is I can just double each one of those lengths. So that 11 plus we'll have 2 times the 8 plus 2 times 7 and then 2 times 6. So we're going to have 22 plus 16 plus 14 plus 12. And we add all of those lengths together, you should get 64. So my perimeter here is going to be 64 feet. All right, now we are on to our final problem for these notes. We have circles A, B, and C are tangent to each other. We have that AB is going to have a length of 11. So this entire thing has a length of 11. Okay, I can note here that these are all going to be a radius, and so therefore these are all going to be congruent. All right, we also know that BC is going to have a length of 4. And AC is going to be 9. we want to find the radius of each of my circles that is given here. And so what I'm going to do is I'm going to just start off with calling the radius of my circle A X. And so that's going to give me these lengths here. And so I'm going to use that to help me find the radius of each one of these afterwards. So here, since the entire thing from A to C is 9, I can subtract that X from 9 to get that the radius for that circle C should just be 9 minus X. Okay, and then I can do that same thing over here, 9 minus X. And so I'm going to start off with that 4, and I'm going to subtract from 4, 9 minus X to find my radius for B. So I'm going to do a little bit of scratch work down here. Here we're going to have that 4 minus my 9 minus X. And so when I distribute that, I'm going to get 4 minus 9 plus X. And so 4 minus 9 is going to give me that negative 5. And so I'm going to just get X minus 5 here. Now, just to kind of mention this, on the other side, well, yes, we do know it is equal, so I could use that X minus 5. I need to set up an equation to solve for X. And so what I'm going to do here is, since I'm just constantly using the same things on each side, I'll never be able to set any of them equal since I have the same thing. I'm going to actually use that the length from A to B is 11. And I'm just going to subtract that X from it. So I get 11 minus X should also be the radius for B as well, right? And this will give me two different expressions that I can then set equal to each other to solve for my X. Okay, so starting off, we'll have that 11 minus X is going to be equal to that X minus 5. Okay, when I solve for X, I'm going to add that X to the other side. So I'll get 2X over here. I'm going to add that 5 over, and I'm going to get 16. And so that's going to give me X is going to be equal to 8. Okay, and so the radius of my circle A is going to be equal to 8. Then I'm going to just plug this in to find each of the other circles' radius. So here for my radius of circle B. Okay, so for circle B, we have that 11 minus 8 because it's X, and you should get then 3. And then lastly, finding my radius for C. We would have that 9 minus X, which is 8. So 9 minus 8 is going to leave me with 1. All right, and there you have it. We now have all 3 of the radius for my circles in this picture.